Nice.
All right, y'all, I'm here with my buddy Schmitty. He's our audio lead on this show. We've done this show for the past couple of years. You've done this show for the past, I don't know.
It's like 6 or 7 now.
6 or 7 years. And
Something like that.
You've seen this show kind of evolve and graduate, pun intended, into what it is today.
Yeah.
So just kind of wanted to talk to you about the show, talk to you about your PA deployment, which we'll get Shats, who's out of frame right now, into the picture for that, because he's the main man when it comes to that. But they do tag team with Schmitty here. Schmitty has years and years and years and years of experience doing audio. So, man, Schmitty, good to be working with you again.
Yeah, of course.
And, yeah, why don't you take us through kind of like, you know, what we're using today, why it's deployed the way it is, and we'll kind of get Shats in there to kind of fill the gaps on that as well.
Yeah, when we started this gig, it wasn't actually quite this gig. We were using a lot of smaller line array. We still did the 4-stripe down the hall kind of idea.
Okay.
But actually they were wider in the center, and we had front fill small hangs in the front. And it's kind of, I don't really know how we kind of arrived at it, but eventually we just said, this is ridiculous. We need to stop doing all of that and just do the 4 main hangs with 4 delays and use bigger boxes. So these main hangs grew to 8 lion per hang. There's 4 of those, so we have 32 in the front main.
Yeah.
And they're zoned the main left and right and outside left and right.
Okay.
And then we added the leopards in the back, and there's 4 hangs of 6 of those to cover the back of the room. We did, one year we tried doing it with just the main hang, and it covered it, but it didn't quite have the presence that we wanted. And because this room is so cavernous, the problem we had, because it's a hall and it's an exhibit hall, it's not a performance hall or anything, but because of the ceiling height and because of how cavernous it was, we found ourselves having to crank the main array, the only array in the room, so high that it bounced so badly in the back that the intelligibility became an issue. So what we did is eliminated that by adding the delays. We pitched the front into the audience a bit more, and we pitched the delays into the audience, and now we've been doing this setup for like the last 3 years, which Chris has been with me on, and it's been great. It's been great.
Yeah.
Client's super happy, everybody's happy, everybody can hear, it's loud. The biggest problem, believe it or not, with a graduation of this size is audience noise. This audience on my front of house dB meter has hit 114 dB.
No kidding.
Yeah, and when they scream and cheer for their kid, this place lights up. I mean, it's like a concert. It's very similar to a concert level audience, and you'd think we were in a rock concert.
And that probably explains why there's so many, not only just for the intelligibility and coverage, but just to pretty much cover your PA in terms of volume to get over the audience.
Yeah, it's exactly, so you got to beat the audience down, literally beat them down with the microphone. So, you know, I've done a lot of concerts in arenas where you almost kind of give up trying to beat the audience up, and you're just like, you know what? If they want to hear the show, they'll quiet down. Right. Because you're pushing the PA's limits, you're pushing the equipment and the PA, and you're just not really getting much further than. And every time you make the PA louder, the audience just gets louder. So eventually you wind up saying, you know what? If they want to hear that, they came here, they paid money to see the show. If they want to hear the show, then they'll settle down. And believe it or not, it actually works that way. They quiet up. But this is not that. This is not that gig.
No.
This is you're fighting with them, and probably the biggest problem that we have as far as competing with the audience is during the walk-in.
Okay.
Believe it or not, that is the time where we really need the announce mic. We have a someone who does announcements for the first 30 to 40 minutes of the show before there's any graduates or even in the room. We have them in here doing general housekeeping announcements, and they're the ones who actually use the PA the most, because they're the ones that have to be heard about. Don't stand in your seats, you can't save seats, you can't do this, stay out of the aisle and all that. And believe it or not, those are the ones that that is the time when we're actually really using the PA system. So that, and trying to get like pomp and circumstance to be over top of the crowd noise, because when they first announce, here are your graduates for this year, this place lights up. I mean, it's that's when you hit 114 dB. And the end, when they toss their hats, when they've graduated and all that, that's when it's
and trying to hear the
good God, man,
music going out.
That's when it's the worst. But
that's crazy. Well, with a PA this size, I'm pretty sure, I mean, obviously I know, but for our audience, there's a lot of connections that were made between speaker boxes, Galaxies and Rios, and there's fiber involved. I don't want to get Shats into this conversation. Shats, if you want to come in frame and kind of talk to us about, I'll go out of frame and you can jump in there, and kind of talk to us about your deployment. If you guys don't know, Chris is on the YouTube vlog before.
Hey everybody.
Last year, and he took us through this deployment last year. It's pretty much almost the same with a couple of tweaks, you'd say?
Yeah.
From last year?
Yeah, pretty much exact same deployment, same amount of PA cabinets we have for fills and the mains flown and the outs. Same amount of processors, but if you all want a little bit more of an in-depth look, we can actually just walk backstage and take you through the overall product deployment we have out there, and then just do a walkthrough from the mains all the way back to the floor, just on how it all comes together, for those that haven't really deployed an active system or even a passive system to understand the IO. But we can do a nice little walkthrough.
Let's do it, and then we'll come back and talk to Smitty on how he time aligned and tuned his PA, because he was using all kinds of noises out here, including his own voice.
That's the biggest noise. Yeah, that is the biggest noise.
Let's go take this walkthrough. All right, we are back here with Shats. We're trying to use as much lighting as we can. Because,
hey everybody.
It's dark backstage, as you can see. We are ready for show. Our show's in about a couple of hours, so
got a little bit of downtime.
Yeah. All right, so cool.
Well, to show everybody, so this is pretty much our processing racks that are carbon copy between the different ones we have across the company nationwide. So it's Furman, 4RU drawer, 816 Galaxy, and then our two MDM 5000s that allows the IO base of power, and our LK multi-pin. So basically this is what drives our signal, 6 channels out, 6 channels of 120 or 208 power. Simple enough. And then as we come around, the one cool thing I like about these boxes is when this W1 has to come into play outside with the MDMs. So basically these are all series W1 panels, y'all can see in there.
Yep.
So in the event I have cross stage patches or multiple ones in a different sequence for however I need, I can end up just getting independent 12 channels coming into here, out of that, into AES. So I can run analog redundancies all the way across, no matter where I need it, or I can, just again, run a direct stage box line from wherever for fills, tie that in there, and I get the same thing. So it makes a lot more things simpler, but back of these systems are pretty straightforward, 6 inputs. Everything to the left is series over to the right, so we get 3-pin outputs. You get 5-pin outputs. And then for those on here who are interested on using these MDMs in the future, just know if you're receiving 120 in the front or 208 in the front, regardless of what the power is, these little power capacitors right here are always 208 out. So if you have any self-regulating PA that's non-self-regulating for the switch, be sure that that speaker can receive 208 before you pop a fuse. So just to let you know, that is a 208 direct out in these P20s.
That's good to know.
Yeah.
That is very good to know. Very, very good to know. Okay.
So pretty much, again, with these systems, what we're doing is we pretty much have individual drive lines. These are our LK and Silca looms for power and signal. And so that's for this side. And of course, we can show the rest. We got our Axion 8-way right here. our ears for our ASL, assisted listening personnel, and for our sign language representatives. Of course, the 3224, we're running everything via SWP. multi-mode fiber for front of house and back to your establish.
Okay.
And then.
So let me ask you a question real quick. So the SWPs, the way ON has built these racks, right? Why is the SWP not in the rack specifically? Is it because you want to have it modular, where you can take a couple racks here, as opposed to just having all these racks in one place?
Yeah, because I mean, a lot of times for different scale of shows, you don't necessarily have to run fiber, so we do have those direct analog. There's sort of 300-foot drive lines, what Byron's asking about. So we, in our company, we have 300-foot looms that are 2130, and then it's 3 EtherCon with a W1 12-channel fan out.
Oh, that's right. Yeah, you do
so
have
in the
that.
event
That's
you're in a
right.
ballroom or whatever site floor where you don't need fiber, and you can't get power from where backstage is at, so you have to get it from front of house or vice versa. You can basically just use that loom and drive everything from backstage to power and base everything to front of house. So
Right.
a lot of times, for these shows, just if you need fiber, keep that standalone. If we built it in the racks, then every single one of these rack systems would have to go out with a fiber reel. And
Right, that's true.
Of course, 750 feet compared to 200 feet, 300 feet. But, it just depends. I mean, what's available? If we have to run fiber, run fiber. Got to run analog?
That makes sense.
We can go analog. It doesn't hurt, but it's nice to have, again, the backups, which we can, if this doesn't work and fiber tends to go out on small shows. So we got RJ45.
There you go.
Either way to be able to get the signal back and forth. But
Cool. So we have I love the way this system is deployed, because you have your Galaxy rack on this side of the house that's driving signal to the PA that's specifically on this side of the house.
Correct.
And then on the other side, you have an exact duplicate with a reel.
Correct.
On that side. And at front of house, you have the exact same duplicate with a Rio as well, that I assume is driving the delays, all the delays on that side.
Correct. Yes.
That's interesting. So walk us through kind of how that's deployed. So this one is taking care of your house right melodies.
So this is taking care. So we have house right subs. All of house right front fills, the stage front fills, and the ones that we have on top of the 700s, and it's going to take care of the house right inside main line and outside main lines. And then so for the other side, we can do our nice little walk-in wonder.
Nice little walk-in wonder. You guys are getting the inside scoop on this one, man. What? Make sure you subscribe.
Yeah.
Make sure.
Basically with this, I mean, as you would do it for any tour, even festival stage, we're always going to have split systems. That way, so the cabling is a lot cleaner, and it's less of a hassle on troubleshooting and of course redundancy. So be able to have independent stage boxes on both stage left and right, drive your PA. That's the ideal way to go if it's possible with gear and production scale. If it's possible for the production to be able to provide that for you, absolutely.
I know you guys can't see us; we're just silhouettes. But hey, the information is there.
So same thing. This is a little bit smaller, obviously over here. So same processing rack, same PD driving it, and of course we're running everything via AAS. So we're doing matrix C outputs to all of our stacks in the sky. And for this one, again, it's on this side, it's going to be the outfill melodies and UPAs, the house left subs, and then the house left main PA. So, and again, that's been the deployment plan just because it shortens on cabling. So if I end up having to drive everything from the house left side all the way back over to A2 land, we'd be at another 150 feet of LK and SOCA.
That would be crazy.
So if something happens to go awry on a cable inadvertently, that's kind of a little bit of a hiccup.
Yeah,
can be a little bit of a hiccup. So, but yeah, these are pretty much our basic systems outside of
you're good
playing hula hoop with XLR.
Is that XLR really?
Or it's SDI, one of the two. And then in the back of here, so for those that do know about Meyer systems, you know about AVB Milan. That's a new network-based system that allows you to you can sync multiple 8x8 and 816, or sorry, was it 4? I think it's 4x8, 4x8 and 816 Galaxies, two different versions. But AVB Milan, basically, if I had AVB inline switches, I would be able to have all of these guys talk, but also I would be able to automatically assign AES inputs and AES inputs at any station off of just one controller, one system. So I can say that I want an AES from this side to then take the signal right here and come out of the other system.
That's beautiful.
So out of the other output. So I can mirror that wherever I wanted to. But for our gear, we're just standard managed 16 port switches in the back. So we're not there yet, but at some point that's possibly be there. You know, of course, all the big gurus that are out with Metallica, they have bigger Meyer PA systems. You know, Ed Sheeran, they're absolutely running AVB.
Speaking of Metallica, I read somewhere that they own their own gear. Is that something I've heard?
Probably they do. I can't confirm or deny on that, but I mean, with that badass Panther system, I'm gonna go see their show in June. Looking forward to it.
That's gonna be fire.
But yeah, Greg and all those guys, man, I mean, they're doing a bang up job. They've definitely done a really outstanding job on the deployment of the Panther rig, and I'm really looking forward to seeing the rigging layout and overall just the deployment, and hopefully be able to talk with the techs on site there. But you know, it's cool what our technology and our tools are able to advance us today to bring so much more of a enlightened experience.
Yeah, man.
To patrons in all formats. So there's pretty much, you know, there's no design and envision we can't deploy nowadays compared to in the past. But that's the fun with the life. So
all right, let's go over to
this
the
is
front of the
backstage.
house and see that rack out there. So here's one of the hangs for the leopards, as I've shown you earlier on the video. And obviously we have a dual hang system here because of the weight capacity on this thing. So those are two 1-ton motors, and the cables run all the way to the back. You can see the loom. I don't know if you can see the loom, but it runs all the way back and all the way behind that screen and down into where we just came from where the Galaxy is. Yeah, pretty much.
And so with this system, if you're ever interested in knowing about Panthers, the Lions, they do not have a power pass-through put. So each one of these take what we call a P32 connector. So there is not any power pass-through. So on the back of here, you saw the Soka overall single line, that's 6 independent channels of power. So I had to use what we call a Soka twofer. So I had to split it because I have 8 cabinets flown and that's 6 circuits. So I do have to split it with a Soka twofer and then take basically a double channel, double circuit, and power up another box, which is completely fine. So these guys can power at 120, 208. The 1100 cells, which we don't have on this show this year, we have 700s. Those are only 208 received. So if you ever are going to fly a Lion, just know that if you're going more than 6 boxes, you're going to have either another Soka breakout, independent drive to it, or do a Soka twofer to fire up the remaining part of your boxes coming all the way down.
I actually didn't even know that.
Yeah.
That's cool.
It's the same thing for the 1100s as well. So you get signal pass-through, but you do not get power pass-through on Lions and 1100s.
Okay.
It's direct 1-to-1. But this year, just like last year, it's the same as that deployment. We're doing 8 Lions, so it's 6 M's over 2 W's.
Explain that for people who don't know what the M and the W stand for.
So that deals with the overall horn degree coverage. So M's are going to be 90, and then W's are 110 in directional width. So
it's wider. You get a wider coverage on the bottom one?
Yeah, so inside the center portion of the baffle, you kind of can see it, but not really. So right down in the center, if you're looking at the box, you have your overall 100-degree horn right in the middle. And on the outside, you have your 2 low-frequency drivers, and then your 1 high-frequency driver in the center. And so that baffle in itself, always down on the bottoms, of course, to get better scope of coverage for our first part of our audience.
First part, right.
So sitting right here, this first bottom box isn't hitting me yet, but we have the front fills right here. As I go back 2 more rows, that right there is perfect. So the coherence between the 2 points, once fills start to dissipate out without killing them, you know, obviously with dynamics, it's shading perfectly at the right spot once those 2 meet up into the field. So as I walk back another 10, 12 feet, that bottom box and that front fill are matching up. So again, no dead zone.
No dead zone. And that's what we go for.
That's what everybody wants to go through. No matter when you're walking through, you're able to hear continuous audible listening level at any point in time.
Very nice.
And what Byron was mentioning earlier, so the reason why we're doing 2 1-ton motors, for PA like this, especially the Lions and Panthers and either big boxes, you always need to end up having 2 1-ton motors. You never want to go dual deck chain into 1 single point. That way, so at any point in time, if there is a failure at one of the motor points, that 1-ton motor can take the weight of the entire rig. So as doing this as an SC, safety is clearly paramount, period. That's my first overall direction and principle is safety. But it's a very simple system to fly. I love the Lions. I can't wait to hopefully fly Panthers. I love the design that Meyer came up with the overall splay and the locking pins. I've flown 16 of these in a large format in arenas and a couple other shows I've done in the past. And it goes up really quick. But definitely having those, of course, it allows you to then adjust how much of a tilt you need going up and back and forth.
That's beautiful.
So, you know.
Pretty much arena style almost through that.
Yeah,
I've seen that a couple times.
Yeah, but having that size of a box, especially for rooms like this, you get a lot more controllability, and of course that helps a lot too. Having that dynamic control and attenuation output. So just for those who happen to be SEs and know what we're doing, the top 2 boxes are independent circuits. My middle 4 are 2 separate zone circuits.
Yeah.
And then my bottom 2 Ws are independent circuits. That's across all 4 main stripes in that exact same configuration.
And let's talk about that a little bit for those who don't really understand what that means. What kind of control does that give you in terms of, adjusting your volume and stuff? Because obviously there's some boxes in this stack that are covering a lot further distance than the ones on the bottom, which are covering closer. So that probably means that your shading is what we call it.
Exactly.
Some of these boxes so that the volume is not as loud for the people that are sitting in the front as it is for there. So it's almost as equal if you measure it correctly. Is that correct?
Exactly, as you nailed it. So on the top 2, that's why I tried up. I mean, if you had the channel count available, so we're dealing with 6 channel breakouts at the end of the LK system in general. So it's a multi-pin system, gives you 6 channels with 2 of the inclinometers. We're not using an enclosed for laser on this because we don't have the systems. But for the 6 channels, that's exactly the reason why I end up, especially for this room, and just usually on most of my deployments, I will couple the top circuits all the way down and then usually use the bottom 3, 6, 5, and 4 for the bottom just to control that shade. But in this case, the meat is in the center right where my main array and the delay array tend to pretty much match.
Yep.
So my top boxes will shoot and hit that far back of the wall, just behind that tail of the last row. And then with the middle though, I want more of the meat for the overall welcoming gathering everybody, because that's a better scope to have those 4 couple boxes to push if we need to get more, and then shade back or push down more on the downstage edge. So having that independent control, what that does, that helps out, obviously, again, like Byron was saying, for shading, delay timing if need be, if something for phase cancellation Y is cutting out in the field. So we can delay time and then filter it differently to match those up. So those overall scales of frequencies will couple and not cancel. And a lot of that has to come into play too, depending on your temperature. So if it was 65 degrees in here, and then all of a sudden miraculously became 99 degrees in here, the high-end frequencies, mid-frequencies, and low frequencies across this entire scope of the room would drastically change. So having that independent control on that scope of a PEA is dire, is absolutely dire. Because as we know in a vacuum for frequencies, sound travels through a medium, but obviously when it has a dense or less dense of environment and temperament, molecular scale of the frequencies are going to travel faster or slower depending on how dense the environment is. Fortunately, we're indoors, so it's AC climate controlled at 70 degrees. But if you ever are doing this in a real world, out in the hot outdoor environment where it's,
hot and mucky in the daytime.
Yeah, well, I mean, it's now 95, 98 from, sound check at 2 o'clock to about 8 o'clock at night, and then your headliner gets on at 9 o'clock at 9:30 at night, and it just went from 95 degrees down to 70 degrees. You're going to notice a big tonality difference of your output, your PA.
Big difference.
So having that control and also working with that to your advantage too. There's not really a right way or wrong way. Obviously, going 1 circuit for 8 boxes, I wouldn't recommend that.
No.
Unless it's a small enough room where you that's all you can do. But if you have the channels of deployability, understanding coupling and coherence to allow the cabinets to work well in summation with each other is ideal. For systems in my mind for this stuff, I always ask myself, if I'm going to make a change, why am I making that change? Listen to the room, use your ears, walk back and forth, and make decisive actions rather than just looking at something and saying, that doesn't look right, let me just shelve it down, let me cut it. Don't do that. Unless, if you're aware that's going to be a problem in the future, sure. But if there's a change that needs to be made, make it. If you don't, leave it alone until you need to make the change. Less is more sometimes in our industry.
Wise words, my friend.
Definitely less is more. It can be. Allow the PA to breathe, allow things to speak.
Agreed.
So,
all right, so let's take that last walk over to the front of house, check out that last rack.
Yeah.
And then we'll have a look at the delays and see what they're doing.
Absolutely.
All right, enter the lair.
Under the sea.
See what we got. Where is our rack?
Right here.
Oh, here it is. So this is our final rack. That's pushing signal and power into our delay boxes, which are our Meyer Leopards. Same schematic. A hang of, how many we got on this one? 1, 2, 3, 4, 5, 6 of them?
Correct. Yep, 6.
6 by 4 going across.
All across, yep.
Just like I showed you earlier. And yeah, this is covering the delays, the back of the room, without having to hit the wall and giving us a slap back, which is pretty well deployed. So talk us through the reason why this was added. I know Schmitty said something about it, but I love the coverage from front to back when you add these delays in there.
Yeah, so this year and just like last year, we started putting the delays. So 3 years ago when we did this show, it was just strictly Lions for mains. We didn't have delays. And while the Lions can absolutely throw 300 feet,
Clearly,
pretty
oh,
well.
Yeah.
They're at a max SPL of about 150 dB. So if any of y'all do one of these boxes, I mean, even D&B and L-Acoustics, and you push one of those cabinets at 145, 150 dB, I highly recommend earplugs because you're going to feel that loudness. So, but also you'll know what the overall limitations are on professional loudspeakers like in this series. But since then, the client has asked us to go ahead and deploy delays, which we're all about, not a problem. They just want a little bit more beef in the tail of the room. And the delays help with that. That way so we can overall accentuate from the mains and not having to drive them so hard. So we just keep, again, for corporate shows and especially your concrete rooms like this, you're gonna get echo, you're gonna have overall room reverberation for the natural environment, the natural overall resonance tones that are cycling around. So even though we have this amount of PA for the mains in general, if you have the deployability of options of the throwing up delays within reason of rigging points and such, it's not a bad idea because sometimes, you can turn off boxes, you can shade them back, it's better to have them up there and not need them than need them and not have them, depending on the configuration and the portability of your shows. Again, this is not a rock and roll show, this is strictly just for intelligibility, for overall vocals and the announcements of graduates. Yeah. And of course to have everybody walking in here and just it feeling like a nice little presentation, nice graduation ceremony for their children.
Making you feel like you're part of the experience as opposed to being in the back and you can barely hear anything.
But if we did have a rock and roll band on here, we are beyond ready to have a rock and roll show in here.
Very quickly.
Big time. So, but for this system, this is pretty much straightforward. So we just have a single drive line going out of my rack, and that's feeding right up to front of house. And so behind this scope up here,
yes, I actually want to go around the back and we can hear you from here, but I want to show people this box.
Yeah.
This is probably one of the coolest things I've seen. And I didn't have this at Georgia Tech because I didn't need it.
No. Yeah, and
but
so
I'm going to try to get a shot of this box because this is really, really, really cool.
Be easy on the overall cabling and everything back here. Don't hate on me too bad.
Yeah, don't hate on him too bad.
But so that little white box you're seeing up there. So what that is?
If you can see, there's a light right in there. Let me see if I can get on this side.
Yeah, there you go.
There we go.
So the white box up there, it basically takes SOCA input and LK multi-pin input.
Yep.
And then those other 4 banks you see on the front side of it, those are split out. So it's just basically a series between the top and bottom banks of your 6 input channels and output channels of signal, and then pass through for power. So if I want to drive another LK loom out of that box, I can.
Yeah.
But again, remember though, it's all 6 channels. So whatever I have coming into that and then jumping over, it's going to match their side.
Yeah.
So what I'm doing in this show, since I was limited to cabling because we are very busy in this season, I am using our 5-pin and pecan looms to basically drive. So across all 4 stripes is a single shaded channel of the top 3 circuits.
Okay.
And that's channel 1. And then output channel 3 is the bottom 3 boxes across all 4 stripes.
I love that.
So most people will be like, why can't you do independent channels? I would if I loved to, and if I had the opportunity to, which I do, but unfortunately that box has been through quite some hiccups in shows, and so a couple of those output channels give me quite the buzz.
Okay.
So so that's where I'm limited to, but it works.
Yeah, but this keeps your cabling so clean because think about it, if you have to run things independently up there, that would be a whole lot of cabling that you'd have to run.
Which is actually fine, yeah.
From each box probably back down to the processor, right? And
well,
this kind of eliminates that a little bit.
What I usually try to do is I'll end up taking 2 LK lines. I'll have one directly going up to a box right here, and then I'll have another LK loom then attached. So basically, I'll do 3 circuits off of this stripe, and then 3 independent circuits off of that one, and then I'll have another white box on that other stripe over there, and then just use those. So I get 3 independent channels on each one of these stripes across all 4 platforms. That one, so then I can just break up my circuits in banks of 2, or I can just do it, top 3, middle 2, or middle 2 and then bottom 1, or bottom 2 independently. Different ways that I feel that I'm going to need to end up shading. But again, for the delays in here, having those couple like that at 3 and 3, it works out. It gives me a lot more of a whole shot for the bottom 3, which is basically where the listening plane for the back of the room, where a lot more seats are until you get into the restrooms and the hole back here.
Yeah.
So, simplicity at its finest, but of course, you deploy with what you got to work with.
Exactly. Exactly.
Sometimes these shows, you ask for something and try to make something happen, and sometimes something just turns awry, and you gotta work with what you got.
Gotta work with what you got.
Yeah. So,
Shats, man, I appreciate the love,
bro.
man.
Yeah, man.
Really appreciate
Thank you.
you. Shats has to go, but thank you so much for all the insight, buddy.
Absolutely.
You're always welcome to this channel anytime, bro.
Yeah, appreciate it,
Appreciate you, brother.
Absolutely.
Thank you, man.
No worries.
Back with the captain. We just did the walkthrough of the system and how it was deployed.
Was that a boat joke?
Shats. No, I don't know.
Because I am a boat captain.
You are a boat captain.
Yeah, I live on a
Yeah,
boat.
I just like calling you Captain Schmitty.
Captain Schmitty.
Yeah, Captain
I guess it
Schmitty.
works. Yeah.
So, Schmitty, with this deployment, I can see that everything is clearly not in line, especially with your delays. So,
I'll say.
Obviously, you had to do some time alignment.
Yeah.
And Chris took us through some of the shading elements of the PA to make sure that your audience has equal level, so we're not blasting anyone's ear off. And we're also making sure that everybody can hear what's happening on stage. So kind of walk us through what your approach is as a front house engineer in terms of when you have a system that's deployed and you're about to now start time aligning it. Everybody has their process. We'd love to know kind of like what your process is, what you've developed over the years.
Well, yeah, I mean, just from doing this for so long, basically you have to establish T equals 0, which is your baseline. And then I use a smart rig, like a lot of people do, and you can do the delay finder and all that, and then you can use the mode in here, which is the transfer mode.
Yep.
Which I'd have to get it all set up, but we've got client in the room, so I can't actually show you. But
Right.
if you click into the transfer mode, well, you can kind of see some of what was happening before, although it's not live.
But these are some traces that you captured in the room.
Well, this is the leftover remnants of a trace. It's actually not the actual trace you'd see. The actual modes that were going on in here, but you use this to align the cabinets, and through doing delay finder and the transfer function, you can actually align it for phase and amplitude. And basically, like I said, you kind of establish T equals 0, which is the closest from the stage or to the stage, and then kind of work your way out, all the way out into the delays. And then you can just set each one and phase and magnitude align it.
Right.
Once you start doing that, it gets pretty easy, but you have to kind of been through a fair amount of system engineering before you really understand exactly how it works. And then the other thing I do is I have a regular straight metronome that I use, and I just use my ears too and make sure that it really is in alignment.
Right.
At the end of the day, I know a lot of guys who've used spectrum analyzers and the transfer functions and stuff trying to align PA, and technically they think they've got it nailed, and then they actually listen to some content and it's way out, and
that
it's
has happened to me before too.
you gotta be careful. You have to have a lot of experience. I started, the first system I ever used was called a Crown Techron, And that was probably the very first TEF analyzer made by Crown Audio, the amplifier guys.
Yeah.
And that system, now I'm really dating myself. So I got one of those, I got in front of a Crown 35 years ago.
Wow, okay.
Actually about 37 years ago is the first time I ever ran across one. The company I was working with went out and bought one. Back then they were several $1,000s. And they worked amazingly well, but they were, that was an old school TEF. And now it's all in the laptop with a little interface and a microphone. And, yeah, you take a sample out of the board, you take a microphone, it finds that delay and you offset it by that much in the rig, and that's your T equals 0, and then you measure each speaker from there on out, and it tells you the delay, and you dial it in, and you just check that it all comes out to 0 and it's up and running.
So here's a common misconception for people who are non-audio guys, or maybe just starting out, because they hear people like you talk about time delaying, and you're able to make sure that the sound that comes out of your delay speakers arrives to the audience's ears at the same time as the speakers that are in front of it. But so you can actually delay these back, but you can't push sound forward. It's physically impossible.
Well, yeah.
I mean, you find some people think that you can do that because there's so much in technology that you can manipulate nowadays, but that's physically impossible for you to push sound forward. You can only delay it back in time. Is that correct?
Yeah. If you can speed up time,
right? Then you can.
If you can advance time, then you don't want to be an audio engineer. You want to be
some kind of physicist somewhere.
Yeah, well, something. Yeah.
Doc from Back to the Future.
Right.
Yeah, exactly. Get out what was that thing? The flux
capacitor.
The flux capacitor.
Yeah, but no,
Yeah,
you're right.
we don't.
Again, physical, natural space and such. As anybody in this industry, especially in audio, look at things in simplicity factor. You have a physical speaker in a single X factor point of your linearity on your field, and you have another one right in front of it. Those two physical portions are not going to move at any point in time. What is going to move is the overall environment. What's going to change is your pressure, your medium in general of how the actual sine waves are going to travel from point to point. But physically, though, those 1 and 2 points are never going to move. So you overall adjusting, accounting for the physical scope is between the A and B, and then what's being pushed out of those to match up in that field, that's the goal, because that's static. Your 2 physical points static, just like here in our realm right now. Our points are never going to go anywhere. We can't push audio forward. But looking at what is capable of the speakers to arrive in a proper amount of time of outside of latency, because again, it's all copper, so it's got to travel from here back there, process, come all the way down, and then reach out there. So as ADD conversions, everything else goes, keeping things simple, so you have less of a conversion factor, getting from the source down to the destination all the way out, and within retrospective, your physical area, your natural space, all those are variables to account for. So for anybody that's new and coming in this industry, don't overthink your deployment, just knowing what you can do, and then do it one bit at a time. Do it in increment baby steps for yourself. Don't try to do a whole bunch of massive things on one system, one PA stack, and then try to carbon copy it to another one, or try to end up making too many adjustments, because then you're going to start shooting yourself in the foot, having to walk backwards instead of doing the baby steps.
Right. Okay. Last words from both of you guys, and this is for our younger engineers or people who want to get into this industry. What does it take? What can I do to practice to become an SE like you, and what does it take to sit in this chair that you're sitting in, Smitty?
Production house. Get your butt in a production house.
That's a good start.
That's a great
starting, learn from your peers and listen a lot and ask a lot of questions. Like the adage goes, there's no such thing as a dumb question, but there are stupid mistakes.
Yeah.
Just ask a lot of questions and find someone who you trust, that that makes it sound good. If you're, if you want to be an SE, you want to be an SE. If you want to be a front of house guy like me, just find somebody who can teach you. I learned from a fantastic mentor who was a Army radio operator in Hawaii. And he taught me everything from wiring to mixing. And, you know, just find a good mentor, find someone who can teach you about it, and listen. Most of all, listen, and, you know, no pun intended, but listen to what they have to say, and listen to your PA, and listen to your instincts. And if any, and you know, as far as like, you know, mixing is concerned and stuff like that, the one thing that I find that most of these kids don't understand, and I've heard about some of the audio engineering schools telling them incorrect information, which is, you know, things about gain structure. In this rig, for example, I'm running this console pretty much at unity all the way through. Every source is dialed up and everything's hitting unity. And in the actual Compass software that controls the Galaxies, I have turned down their inputs. Because if, above all else, you want your noise floor and your gain structure to be right coming out of the console, and then if the PA's too loud or not loud enough, you want to make that adjustment at the, you know, at the processing side of it, or the input gain to the, you know, the amplifier or the speaker itself. Yeah. I've had a lot of people come to me and say, oh, you know, you can, these are digital consoles, you can run them way low and they're clean and they're digital and all this, but they don't understand noise floor and how it gets into the rig, and they don't understand dynamics. And if you don't operate your console in the right spot, you know, it's obvious what you're doing. So
yep.
The biggest thing is to start here and work your way, you know, forward. So, you know.
Nice. Yep. And to piggyback off what he was saying, so if anybody's trying to get in this industry, there's lots of cool free classes. Shure has a wide plethora of free learning material for all their units and products, between especially wireless coordination and RF. Audinate with Dante has the same thing. You can get free classes off of that and become Dante certified. But outside of being production houses, engineers like myself, if you have buddies that do this with one-off productions in your local area, ask if you can come out and shadow with them. You know, as a pro bono day, come out and say you're not going to work, but you just want to shadow, be along his or her hip, and watch what they're doing, how they're deploying the rig, how they do monitors, how they do front of house, how do they even run power, how do they even dial up, you know, going and get their gain structure set, deploying microphones. And then another thing is understanding PAG. A lot of people, I'll piggyback in from gain structure, potential acoustical gain. Learn that, understand that in the geometric space from your source off of your stage, from your first microphone to your PA. If you can understand what between gain structure and PAG and overall physical acoustics in your environment, those three things right there, that's a good fundamental learning platform. But if you can get in a production house with engineers like myself or anybody else in your local area, and just even when you go to festivals, talk with the overall engineers at front of house. A lot of them are really cool cats, they're really cool people, and they can point you towards to someone locally who might have a production warehouse for you to go in and freelance or work with, and then start, you know, upping your knowledge. And that's the best way to learn, is get your hands on the units that you're going to see in the field, but you're not in a rush. You can sit there and mess with it and learn from it, and you know how the operation unit works to its full capacity. So that's what I recommend.
I love it.
Yeah.
I love it, guys. Thank
Absolutely.
you so much, man. I really appreciate y'all for your time, man.
Cool, no worries.
Absolutely.
Yeah, man. Absolutely. You have a great day. Thank you.